right, so today we're going to talk about congruent triangles, namely the special isosceles triangles, equilateral triangles, and right triangles. Now, so far we talked about four shortcut ways of proving two triangles congruent, any triangles congruent: the SSS, SAS, ASA, AAS. And then we briefly talked about HL, which deals with the right triangles. We're going to kind of talk about that in more detail today. And so the vocabulary about base angles, just know that the base angles does not necessarily mean that it's at the bottom of the triangle. So, if you look at here, the triangle is kind of flipped upside down here. And so the base angle is not necessarily at the bottom. So in this case, it's on the top, right? And so sometimes it'll be on the side. And so this is the isosceles triangle. And so the base angles are always the two congruent angles that's opposite to the two congruent isosceles sides. And sometimes it's located on the top, sometimes it's located on the right side or the left side, right? And so the vertex angle is the angle that is not the same as the two base congruent angles there, right? So that's some basic vocabulary terms that we're going to be using. All right, so we have some theorems here, which seems kind of obvious. We have a base angles theorem. Now, again, here, the base angles are on the right side here, not necessarily at the bottom, right? And so sometimes the picture is tilted sideways. So what this says that if you have two sides of any triangle that are congruent like this, then that also tells you that's isosceles, right? Which tells you that the two base angles are also going to be congruent. So you have isosceles, two sides congruent, then you're going to have the angles, two angles, which is sort of opposite to the side here, and then this angle is opposite to this side. So those base angles are also going to be congruent. Now you can say that backwards, which is the converse of the base angle theorem. And so that's, if you remember the converse, you switch the if and then, the hypothesis and the conclusion. And so you can start out with the two angles, in this case being congruent, right? So if the two angles are congruent, well, that also tells you that the two sides are going to be also congruent. And so that's basically the kind of information that you can say about isosceles triangles. So you can start out with two sides, and then that means two angles are congruent. You can start out with two angles, that means the two sides are congruent. So that's just a couple of theorems dealing with isosceles triangles. And then the corollary, if you remember, follows the theorems, which is kind of obvious, right? And so if you look at the base angle theorem, if you start with the two sides, and then if you start with three sides, right? So that means all three angles are going to be congruent. So that means not only isosceles triangle, but if it's an equilateral triangle with three sides congruent, then it's also going to be equiangular, which means that three angles are also going to be congruent. Same thing with the other way around, right? If you start with three angles being congruent, that's the equiangular. So if you start with three angles congruent, well, that automatically also means that the three sides are going to be congruent. So it seems kind of obvious, but that's why it's a corollary. It seems kind of follow these couple of theorems in an obvious. These two theorems deal with two sides with isosceles. This deals with three sides and three angles for equilateral, equiangular triangle. Right? So that seems kind of obvious. All right, so then if I have pictures like this, right, it's isosceles triangles, sort of, two isosceles triangles sort of merged together like this. And so using the isosceles triangle, we can figure out the value of y, which is the measurement of this angle here, right? And so we know that these two isosceles sides, which means that this angle and this angle is congruent, which means that 70 degrees and 70 degrees. Well, not only these are isosceles, but this is isosceles as well, right? So all three sides are congruent, but this is also another isosceles triangle. So that means this angle and that angle is going to be congruent. Now, that does not necessarily mean that it's going to be 70 degrees, right? Now, we know these two isosceles sides means these two angles are congruent. Now, these two isosceles sides here means those two angles are going to be congruent, but they're not necessarily going to be congruent to this one because they're not, as you can see, obviously, they're not congruent triangles. They just happen to be isosceles triangles connected together. So then how do we figure out the measurement of angle y? Well, using the linear pair, which is these two here, right? That's a straight angle. So this is 70 degrees. Well, you know that's a straight line, straight angle. That should add up to 180 degrees. So that means this angle here, the vertex, should be 110 degrees, because 110 degrees plus 70 adds up to 180. So then using the triangle sum theorem, we know that triangle here on the right has to be 110 plus y, and then this is going to be same as y, whatever that y is. And so we add 110 plus y, which is 2y, and the triangle sum theorem tells you that's going to add up to 180 degrees, right? So we use the isosceles triangle to say that these two base angles are same, so that's why it's 2y. And then we figured out this one using the linear pair postulate. And so then we subtract 110 to cancel that out on both sides. And so then we end up getting 70 degrees here. And then we still have 2y here, right? Because there's two angles. And so we divide by 2 to figure out y. And so we get y equals 70 divided by 2, which is 35. So y is going to be 35. That means this is going to be 35 degrees. And then that's also going to be 35 degrees, which is isosceles. And then 35 adds up to 70, plus 110, that adds up to 180 degrees. And so that all adds up all together, right? And so that's using the idea of isosceles triangle. So if the two sides are congruent, then the two base angles are also going to be congruent as well, okay? All right, so then we can also figure out some of the other information here, right, using the isosceles triangle. So which means that because these two sides are same, the two base angles here and here are going to be congruent. So that means this is 75 degrees on the left side, so the right side is going to be 75 degrees as well. So then whatever the 5x is, that's also going to have to equal to 75 degrees, right? And so you can figure out x by dividing by 5 on both sides. So then the x is going to be 15, right? So x is going to be 15, which means that if I plug in here, 5 times 15 is 75, so that's 75 degrees and 75 degrees. And so if I add the two 75, 75, that's going to be 150 degrees, right? And so I do 180 minus 150 degrees, right? Because the triangle sum theorem tells you the three angles are 180 degrees. I know these two are 75, 75, which is 150. So that means you subtract. So that means this angle is going to be 30 degrees right here. So then you let 3y equals 30 degrees, because that's what it has to be, and then divide by 3 on both sides. So then the y has to equal to 10. So then 3 times y is obviously 10, so that is all added together, and that's all connected together, and they're all correct. Okay, same thing with the other triangles here. Now there's several triangles here. This is isosceles here. This is equilateral in the middle. And then this is another isosceles here, right? So this is 70 degrees, which means that that's also 70 degrees. Why? Because this is isosceles here and here, right? So that two base angles are going to be congruent, right? That's the base angle theorem. So 70 plus 70 is going to be 140, right? So then we know triangles add up to 180 minus 140 for these two. So that's going to be 40 degrees for the other one here. So x is going to be 40 degrees, right? So then 40 plus 70 does add up to 180 degrees, right? So then here we know that the this is 70 degrees here, and we know that the angle, these are all 60 degrees. How do we know that? Because that's equilateral triangles in the middle. So equilateral means that it's also equiangular, which means that it's going to be 180 divided by 3, which is 60, because 60 plus 60 is 120. 120 plus 60 is 180. So we know this is 70. We know this is 60. So then we know this angle here, I'll mark it with 2, that has to be 130, right? The 70 plus 60 is 130. So 130 plus 50 is 180 degrees. And so all of three of these angles here have to add up to 180 degrees. Why? Because that's a straight line here. That's a straight angle, which is 180 degrees. So 70 plus 60 is 130. 130 plus 50 is 180. So we know that vertex for this isosceles triangle here on the left is 50 degrees. Well, we know y here has to be same as y there. Why? Because that's isosceles, that's base angles. So again, we got 50 degrees plus y, which is 2y, and that has to add up to 180 again, because that's a triangle sum theorem. Any triangle always add up to 180 degrees if you add all three angles. So once again, you subtract 50 on both sides to cancel that out. And so that's going to be 130. And then we still have 2y here. So divide by 2 on both sides to solve for the y here. And so that's going to be 65 for the y. Okay, so that's how you can use the idea from the equilateral triangle as well as isosceles triangle to solve for some of those variables, some of those angles that is represented by the x and the y there. Okay, next. All right, so then we talked about hypotenuse leg before briefly, so that's a theorem now. So we're going to kind of go through this again. So hypotenuse leg represents for any right triangles, right? If you know the hypotenuse is congruent to the hypotenuse, and one of those two legs, right, doesn't matter which one, is congruent to the other leg, then just having the hypotenuse leg congruent, knowing that these are two right triangles, that is enough to say that these two right triangles are congruent. And so this is another shortcut that we talked about briefly before, right? And so we're going to kind of look at this in a little more detail. So how do we use hypotenuse leg to show the two triangles are congruent along with the SSS, SAS, ASA, AAS, and now we have HL. Remember, you cannot use AAA, right? You cannot use ASS, which is backwards of SSA. So don't call AAA or don't use your ASS, don't use your but to show two triangles are congruent. But now you have these 5 methods to use a shortcut to show any two triangles congruent. All right, so let's take a look at HL in more detail. And so we have this volleyball net here that is held by this, pole that goes straight vertical to the ground, right? So that's perpendicular, right? Which means that it's right angle. And then you got these 3 strings here that is kind of tying down the pole and the net on the ground. So these are all on the ground. The pole is, perpendicular to the ground, obviously. And then these ropes are tying down at these different locations on the ground, right? But then we're going to use the same length rope here. So we're given that the XV and the YV and the ZV, 3 ropes are all congruent, right? So I marked it. And then we're given that the pole here, which is represented by the VW, is perpendicular to the ground. So that's perpendicular here. And then this rope here, I know it looks a little strange, so I kind of drew it separately here. Even though it may not look like it on the picture, that also is represented by a right angle there because that's perpendicular on the ground. So that's the pole, and then the rope just goes from the pole. So that is perpendicular on the ground. So the rope and the pole represents all right triangles on all 3 of those triangles that's represented by the 3 ropes, right? So I copied all that information, right? All that perpendicular to the pole to the ground, and then the 3 ropes are congruent. So I just, use that. I just copy all that as the first step, and then that's given, right? So all that information is given to us to start with. And so I marked all that given information here on the picture, right? And so because the pole is perpendicular to the bottom on the ground here, all these are right angles, right? And so the fact that they're perpendicular to the ground, that means all those 3 angles are right angles. That's the definition of perpendicular lines, right? So that's definition of perpendicular lines. So if 2 lines are perpendicular, then it forms the right angle there, right? And so now that establish is that these three triangles are all right triangles. Well, so then we knew that the hypotenuse of those three right triangles are all congruent because that represents the same length rope, right? And also the pole represents one of the legs. So the pole is congruent to itself on all three triangles. So we got the hypotenuse leg congruent to the hypotenuse leg and congruent to the hypotenuse leg on all three triangles. That's represented by the pole and the rope and the ground. And so the VW is congruent. That's the reflexive. That's the pole, right? So that's the reflexive property of congruence. And then once we establish the hypotenuse and the leg for all three triangles are congruent by the hypotenuse leg congruence theorem. So that's the hypotenuse leg for the right triangles that we can use now, right? Anytime you see right triangles and you know that the hypotenuse are congruent and the one of the two legs are congruent, it doesn't matter which one, then you can use HL to establish or prove that any of those triangles are congruent. So that's how we use HL congruence theorem. Okay, let's take a look at one more proof. All right, so here is another kind of intertwined triangles here. And so what you can do is sometimes separate the pictures like this. It would make it easier. So I'm looking at the triangle RTV that I'm trying to show and prove that's congruent to SVT. So I separate the two triangles. So here's the RTV, and then here's the SVT, right? And then I know that I was given that the RV is congruent to ST. So I mark RV congruent to ST. And then I know that these angles here, the RTV and the SVT, are right angles. So I mark the right angles there, right? So then I'm just going to write that as the given information. So you always start with the given information, right? And then I know that the TV at the bottom is congruent to itself, right? So this TV is congruent to that TV. Why? That's reflexive again, right? We saw that quite a bit. So remember, you can use that reflexive property of congruence, right? And then once I establish that, I know it's the right triangle, right? I know hypotenuse are congruent. I know the leg is congruent. So then, therefore, these two triangles are congruent by HL congruence theorem. So using HL sometimes could be easier because you only have to know that the two triangles are right triangles. And then you just have to make sure that the hypotenuse are congruent. And then just the one side, which we call leg, is congruent. And so that's how we establish two triangles are congruent using HL congruence theorem, which is for the right triangles only. Okay? All right. Thank you.